Welcome back, welcome back, welcome back. This is Miss Lisa's YouTube channel. I can say that. And I want you to like, share, and subscribe. I have a goal, 1,000 subscribers, so I'd like you to be a part of me reaching that goal. So this is part 2 of chapter 13 of physics, talking about the states of matter. But you don't have to be a part of this class. If you like the way I explain this math, come on and join us. We're going to be using our TI-84 graphing calculators, my favorite calculator, and doing some of the math problems that have to do with this. Okay, so the first one in the book is this. It says, a typical high school student weighs 725 newtons. So the first thing you write down, you just list the numbers, tell what they are with units, and then because our goal is to get rid of all the words and just have the numbers. The numbers are the easy part. And wears shoes that touch the ground over an area of 412 centimeters. So my area is 412 centimeters. A, what is the average pressure his shoes exert on the ground? Well, newtons have meters in it, so we need this to be in meters and not centimeters. So first we're going to change it using King Henry's Daughter Bakes Delicious Chocolate Muffins. I'm at centi. I need to go to the basic unit, meters, so I move the decimal place 1, 2 places, 1, 2 in that direction. So, and actually, where did I have it here? It's on another piece of paper. Because of it being squared, I wrote cubed there. That should have been squared. That is really, you use a dimensional analysis one with that. So you can look up how to do that. But anyway, just know that we had to convert it, and that's what it ends up being. 1, 2, 3, 4 places you move it. Okay, so let's just look at the math part. You can look up that later. Okay, because I have it on another piece of paper that is actually not here where I can show you. And I got one hand for the phone and the other hand to point, and I can't show it to you right now. All right, so the area goes on the bottom, the force on top, because pressure is force over area. So the next thing we do is we say, is there a formula that relates force to area and pressure? And that's it. P equals F over A. The force is 725. The area is 0.0412. So that we just divide. So you should know how to do that on your calculator. This is the regular math screen. I want to clear it out so it looks good. And I do 725 divided by 0.0412. And that is that number. And that it would be in pascals, but they converted it in your book to kilopascals, going from basic to kilo back here. Basic to kilo is moving the decimal place 1, 2, 3 places. So it's 17.6 rounded off kilopascals. It sounds like you're doing something bad to poor Pascal. He's getting killed. Kilopascal. All right. So for B, how does the answer change when he stands on 1 foot? Well, if he's only standing on 1 foot, then we take our area divided by 2, and it's 0.0206 meters cubed. Should be squared. Should be squared, not cubed. Yep. Should be squared. Should be squared. I don't know why I kept writing cubed. So it's the same formula. Pressure equals force over area. 725 over 0.0206. That's it in pascals. That's it in kilopascals. So my work was really the same as the book work on that one. Sometimes I do it different. They like to get stuff on one side, and I don't. I like to fill it in first. Okay, problem number 2. A 20 Newton force, so I wrote that down first, 20 Newton force, is exerted on the small piston of a hydraulic system. The cross-sectional area of the small piston is 0.05 meters squared. So area 1 is 0.05 meters squared. What is the magnitude of the weight that can be lifted by the large piston, which has a surface area of 0.1? So area 2 is 0.1, and what they want is force 2. So pressure 1 equals pressure 2. That's what this little drawing is about. And it's how hydraulic lifts and stuff work. And so if the pressures if the pressures are equal, each pressure is force over area, we can say force 1 over area 1 equals force 2 over area 2. We can put in what we know, substitute it in, sing the song Substitute, put an X for what we don't know, and cross multiply and solve for X. So 20 times 0.1 equals 0.05 times x. Y is x not alone, is being multiplied by 0.05, so divide by both sides by 0.05. So on your calculator, you would do. Now, I like to use the little alpha y equals fraction thing, numerator divided by denominator. And now I can say 20 times 0.1 in the numerator, arrow down, and in the denominator, it's 0.05. Enter. And it says it's 40, and the answer is 40. Yay, go us. We figured it out. We got it, that was 40. Okay, moving right along. That's a good little lab that you can do for your homework. You'll have to look in the description and see what I assigned for you. All right, a cubic decimeter of steel is submerged in water. Okay, so our volume is 0.001 meters cubed. What is, and so this is our buoyancy thing, density equals mass over volume. It says, what is the magnitude of the buoyant force acting on the steel? So the pressure of the steel, P of steel, is 9,000. For the water, it's 1,000 because we're putting it in water, so that's how much the water is. So what we're trying to figure out is the buoyant force, and it is equal to the P of water times V of G. So that means we multiply our 1,000 times our 0.1 times the acceleration due to gravity, and it's 9.8. Now, in your book right here, they have a typo. Over here, you see that it is 10 to the third, and here they put that it's 10 to the negative 1. And it should be 0.001 or 10 to the negative 3. They did the math right, but they wrote it wrong. If you use their number, you won't get the right answer. You got to use the right answer that they gave you in the given to do the problem. So don't let that fool you. Yeah, I know it's weird that sometimes even books that have been published for years, can have mistakes in them. In high school, I had this Spanish teacher who would sit there and read the book real carefully for mistakes. And when he found mistakes, he would write the publisher and say, there's a mistake on this page. And they would send him money for it. He would sit there reading the book in class while we were supposed to be like translating something. And he'd get little checks for money. I've never told the manufacturer that there's mistakes in the books. I just always tell the kids, there's a mistake in the book. All right. B says, what is the apparent weight of the body? The density of steel is 9 times 10 to the third kilograms per meter cubed. So to get the weight, the apparent weight, it's the mass times gravity minus the buoyant force. So this is 0.01 times 9,000 times 9.8 minus 9.8. And it's 78.4 newtons. Okay, that was pretty easy too. Okay, let's see. I think we have a fourth one to do here. Where'd it go? Where'd it go? Still can't find it. There it is. This one has to do with the fact that things expand when they're heated. Okay, a metal bar is 2.60 meters long. So length by tradition is written in cursive, so I wrote it in cursive, 2.6 meters long. The bar is heated uniformly to a temperature of 93 degrees Celsius. There it is. And the change in length is measured to be 3.4 millimeters. Okay, and you know, if this is meters, that's going to have to be meters. King Henry's daughter bakes delicious muffins. We go from millimeter to basic, 1, 2, 3 this way, 1, 2, 3 that way. There it is, 0.0034 meters. Okay. What is the coefficient of linear expansion of this bar? Okay, and the other temperature was 21. I think I forgot to tell you that. The first temperature is 21. It's heated to 93. We need to know the change in temperature, the delta T. So that's T final minus T initial, or T2 minus T1. 93 minus 21 is 72. So now what they want is alpha. So we put it in our formula. The change in length is equal to alpha length 1 times the change in temperature. So the change in length was 0.0034. Alpha is our unknown. 2.6 is our first length. And 72, that should have a little in parentheses there. Let's see if I got my pen here. Oop. Some more fun with sound effects. And y is alpha not alone. It's being multiplied by 2.6 and 72. So we do the opposite. We divide both sides by 2.6 and 72. And this is what you get on your calculator. And they rounded it off to 1.8 times 10 to the negative fifth. All right, and that's it for chapter 13. I think it's pretty easy. So y'all have fun with it, practice it, do your work, and next time we'll come back and talk about waves. Have you ever been surfing? I have not, but it looks fun. I think I'd like to try it. All right, math is great, science is great, physics is great, and like, share, subscribe. I'm Miss Lisa. See you next time.